This is a great question on arranging digits. We're asked how many four-digit integers from 1,000 to 9,999 have at least one digit repeated. So you could take a number like 8,888, and then you have one digit repeated four times, in fact. 8878. Again, it's still being repeated. 8865, still repeated. It's only when you get onto something like 8765 that it's not repeated. So we're interested in all of these numbers. But actually, it's going to be easier to look at ones where no digits are repeated. Because then, if we look at the total number of numbers, we've actually got 9,999 minus 999, because I want to include the 1,000 in it. There's actually 9,000 numbers we're interested in. Another way of doing it is to do 9,999 minus 1,000, but then you have to add 1. So 9,000 numbers. So I'm actually going to look at no digits being repeated and then subtract that from 9,000. Let's consider our number then. Now, our number cannot start with a 0 because it's necessarily 4 digits. So this can be any number from 1 to 9. And therefore, there's going to be 9 options for my starting digit. If I now look at B, well, it can now be 0 for once, but it can't be the number that I've just considered. So let's say it was an 8, it can be from 0 to 7 and then 9. That's if this one was an 8, by the way. Of course, it's going to all depend on what A was, but it's going to be any of the 10 digits except what I picked for A. There's actually going to be another 9 options. And if I want the number of options in total, well, for 8, there's 9 options, but for 7, there's 9 options. 6, there's 9 options. Because there's 9 options here and 9 options here, I actually multiply them to get the total number of options for my first 2 digits. Now for C, arguing along similar lines, it just have to be different. Well, I had 9 choices here. Okay, because remember I had this extra choice of 0, so that's why it's 9 and then 9 again. But now there's only going to be 8 choices, and I'm going to times them all together to get all the different arrangements of these 3 digits. Because for every single digit I have here, there are 81 or 9 times 9 possibilities here. So I can cycle through all 8 and have 81 for each of them. That's why I times now by 8. And then finally, there's going to be 7 options for D. So my answer is going to be 9,000 minus 9 times 9 times 8 times 7. It's just how do we now simplify it and write it like one of these numbers? I don't really want to kind of work this out, subtract it, and then, see which one it is equal to. That would work, to be fair, but let's try and do it another way. Right, well, first of all, I can see that there's a factor of 9 in both of these. So I'm actually going to take it out. So it's going to be 9 times 1,000 minus 9 times 8 times 7. Actually, 8 is also a factor of 1,000. 9 doesn't go into it, 7 doesn't go into it, but 8 does. So I can actually take the 8 out as well. And I'll divide 1,000 by 8, which is 125. So I'm going to get 9 times 8 and be left with 125. 8 times 125 is 1,000. And then I'm going to also factorize the 8 out of here, so it's going to get 9 times 7. Right, this is looking good because actually I get 72 from this, which is in 2 of the answers. 72, and I just need to do 125 minus 63. And that is just 62, which is the final answer. So that is a really neat way of doing this question. Instead of looking at all the different cycles I can have with at least one digit being repeated, of which it's going to be pretty complicated. I've looked at the simpler case of no digits being repeated, argued what that would equal, not worked it out, but subtracted it from 9,000. We see in the final answer we have it as a multiplication. So by taking it steady, factorizing numbers out, it nicely comes out. I'm not saying that's easy to do, but this is this is a neat solution that we can write.